go to your workbench, Ansys workbench apps here, and then you can see inside the toolbox on your left side of your screen, there's many of the Ansys system that you can choose. So for today, we are going to use static structure. Click on the static structure and then drag it to here, to the green box here. After you drag it there, you can see the Dropbox of a Dropbox like this, and then you can see the engineering data is already there, which means that the data is already there. Now we're going to continue with the geometry data. Double click on it, and then you can see here it shows starting discovery, and then we will open your discovery Ansys discovery app. It will take kind of long time, depends on your laptop system. Okay, so now you can see my Ansys discovery screen. When it is open, you have to give it some time to relax so it can function well. Okay, so for today's activity, we're going to create a rectangle 3D object, a 3D rectangle, so we can apply force to it. So in this application, Ansys discovery, there is on the sketch side, there is rectangle here. Click, and then you can choose the middle between both x and y axis, and click it. Click, and then you can drag your mouse wherever you want. And as for me, I want it to be 10 and 10, so I can, when I extrude or pull it up, I can create a nice rectangle with square base. Okay, then I press enter. Here you can see I have my square here. And then next step is choose this hole. I choose that hole and go to the middle, drag it upright, and do whatever I want. Maybe 20 is enough. Then while I am holding the left click of my mouse, I type insert in 20 and then press enter. Alright, so this is our geometry for now. It is automatically saved when you click on the close button. So after you're done, you can just click on the close button and then it will save your design. Okay, so now you can see the geometry is already there because it had your data already. In the next step, choose this model, double click on this model, and you can see here it is starting mechanical. It will start the mechanical branch of Ansys. So it's not going to take that long, but you still have to wait for it to open. once it's open, it will automatically show you your geometry, which is what you have done before. But for this, we've done it vertically, but actually we want it to be horizontal. So this apps already know what we wanted, and then put it on the horizontal line, horizontally, so it's easier for us to use it. And then you can see on your left side of the screen there is so many things that we have to go and analyze one by one. First, we're going to go to materials, click on this plus box, and then here is where we're going to see what material is this geometry is. And then you can see it's structural steel, which is what we want, structural steel. So there's no need for us to change it or anything. And then next is the mesh. We have to generate this mesh for this rectangle. So right click on this mesh, and you can see generate mesh. Click it, and it will generate the mesh for you like this. See, all the little square for this mesh. Then next, we are gonna apply. You're gonna apply force to this, but before we apply, we have to choose one plane to have our fixed structure there. And before that, we have to right click on the static structure. Right click on this, insert fixed support. With this fixed support, we can prevent that plane from moving or deform. Okay, click on the fixed support, and then we're gonna apply it on this side of the plane. So click on your mouse scroller. Okay, after you click, you can move it around. Then we want this one. Click on this, and then click apply. Alright. Okay. After you click apply, then we're done with this plane. You can go back to if you want to go back to your view just now, you can go to this view and you click on it, then we can go back to our view just now. After we have fixed the plan, we can apply force by right clicking the static structure, insert force. Okay. This force, we want to apply it on this plane, then click on apply. Okay. We don't want to use vector here. We have to change it to component, and then we can choose what component that we want. For this experiment, we want our y component to be our force to be in y component. So use this y component, and we also want it to be down direction of one y component, which means negative y component, and the value of the force is 500. Okay. Click anywhere so it is safe. Alright, we're done with force. So now we're going to check the deformation, the stress and strain. So go to solution. Okay, insert deformation total. Next, insert strain equivalent. Next is insert stress equivalent. So here, the solution will give us what we want, which is total deformation, equivalent elastic strain, and equivalent stress. Okay, so if we want the answer for this, all of this, we can go right click to the solution and click on solve. Okay, on this left side of the screen, it will show you the status of the solving just now, and it will show you 78% and everything. Okay, so now we are done. We can see here how it is that status is already done here. Okay, and then we can go to each of this to check our result. So total deformation, you can see here is the maximum force, and then here is the minimum force applied, and we also fix here, so it is not moving at all. Okay, so we can also use this button play to show us the animation of the force applied. You can see here it is not moving at all because we already fixed the support here. Okay, this is for deformation. And next is equivalent elastic strain. You can see it's everywhere. The minimum is here, and the maximum is on the edge of this side only, where the other side is not that much force is the field, the rectangle field that much force. So you can use this to see where it is started. So we actually put the field support here, but it also feel the force, but not that much. As you can see, it's already there's some place here that is still blue in color, which is only feel minimum force. Okay, here you can see. Next is equivalent stress. You can see stress also the minimum stress applied is at the edge of this here, and then in the middle of here. Also, it does not feel that much because we can see the red is very small here. Also the orange is also very small. Blue is really big, which is the minimum force is applied here. Okay, you can see using this animation. Okay, the force applied here and here, it is not that much. I think it is very kind of similar to what strain is. It is not bending that much. You can see when you bend a little, go back to elastic strain to see the bending. Also very little bending. It is very minimal force applied here. And then here you can see pretty much more bending than other. So that's it for the experiment for today. Thank you.